We are looking at trace theory, and we showed that there is a sequence of maps gamma j which you can define on the various suburb spaces Hm of Rn plus, and gamma naught of u is nothing but u restricted to Rn minus 1, and gamma 1 of u is nothing but du by d nu, the exterior normal derivative, restricted to Rn minus 1. D by d nu in this case is minus d by dxn, because xn is the unit outer normal. So this is the minus En is the unit vector normal to the boundary of Rn plus. Okay, so this is how, and then gamma 2 would be d2u by dn square, d nu square, and so on. So you would get various things. Now we want to study the kernel of this map gamma naught. Okay, so now we already have, so we will show, so claim kernel of gamma naught is in fact H10 of Rn plus. I've been talking about this for a long time. Various propositions were proved to show that if something vanishes on the boundary or vanishes outside a compact set, then it is in H10, and so on and so forth. So now we will finally, this is the last word on it, namely if the boundary value is 0, then it is in fact H10. So if you have that, so you know that d of Rn plus is clearly in the kernel of gamma naught, because d of Rn plus are C infinity functions with compact support. So the gamma naught of that is nothing but the value on the boundary, and that is of course 0 because it has compact support inside. And then this is a closed subspace. Kernel gamma naught is a closed subspace because it's the kernel of a continuous linear map, and therefore this implies that H10 of Rn plus is contained in kernel of gamma naught. So we need to prove the reverse inequality. Okay, so we have to show the reverse inclusion, namely kernel of gamma naught is in H10. That will prove the theorem. For that we need some technical results before. So we have lemma. This is Green's formula, which we have used many times, integration by parts. Okay, so let uv belong to H1 of Rn plus. Then integral over Rn plus u dv by dxi dx is equal to minus integral over Rn plus of du by dxi times v dx for all 1 less than equal to I less than equal to n minus 1, okay, and integral over Rn plus u d by dxn v dx is equal to minus integral over Rn plus du by dxn v dx minus integral Rn minus 1 of gamma naught u gamma naught v dx dash. Okay, so this is the Green's formula when you have, so proof. So let uv belong to d of Rn. Then both these relationships follow by, this is just integration by parts. Okay, because you have integral u dv by dxi dx over Rn. So for this Rn plus is equal to minus integral du by dxi v dx Rn plus, then plus integral on d of Rn plus u v into nu I. Nu I is so nu equals nu 1 nu n unit outer normal on d of Rn plus. D of Rn plus is nothing but Rn minus 1, and nu is equal to minus En, and therefore it's equal to minus 0 etc 0 minus 1. Okay, so if you substitute this, you will get both these relationships immediately, and uv on the boundary is nothing but gamma naught gamma u, and now result follows by density. And continuity of the trace map. Gamma naught from H1 of Rn plus to L2 of Rn minus 1. Okay, so that proves the first relationship. So corollary, uv in H1 of Rn plus, if one of them at least one of them is in kernel gamma naught, then integral u dv by dxi dx on Rn plus equals minus integral u dv by dx du by dxi v dx on Rn plus for all 1 less than equal to I less than equal to n. This is obvious because you have for 1 to n minus 1 you already have this relationship, and the last one, the boundary term vanishes because gamma naught u or gamma naught v is 0. So therefore you have this relationship for all the values 1 less than equal to I less than equal to n. Okay, so next corollary, let v belong to kernel of gamma naught. Let v tilde denote the extension of v to Rn by 0 outside Rn plus. Then v tilde belongs to H1 of Rn and dv tilde by dxi equals d by dxi of v tilde for all 1 less than equal to I less than equal to n. So we have already seen this kind of thing for H1 0 of Rn of any omega. If you extend by 0, then you know that it is in fact the extension by 0 is in H1 of Rn. Now we are showing for kernel of gamma naught. So because after all our ultimate aim is to show that both these sets are one and the same. Okay, so let phi belong to d of Rn. Okay, then integral over Rn v tilde d phi by dxi dx equals integral over Rn plus of v d phi d phi by dxi dx, and now because of the previous corollary we can write this as, because v is in kernel gamma naught, so this is integral over Rn plus dv by dxi times phi, which is equal to minus integral over Rn of dv by dxi tilde phi dx, and that proves the result. Okay, so that proves the corollary, and you have immediately the thing. So now let V belong to H1 of Rn plus. Let H be greater than 0, and you set H bar, the vector, to be H times En, where En of course equals 0, 0, 1, the basis vector, nth standard basis vector of Rn. Okay. Now you consider tau H V tilde. Okay, V tilde is the extension by 0 outside. So tau H of V tilde extension by 0 to Rn outside Rn plus. Okay, so tau H of V tilde vanishes for all x in Rn such that xn is less than h. Because why? Tau H of V tilde at any x is V tilde of x minus h. Now V tilde is 0 if so x n minus h is less than 0, implies V tilde is 0. Okay, so V tilde of x minus h, and therefore the xn less than h, it has to vanish. So what are we doing? We are just pushing the function this is Rn minus 1, this is xn, and we have here V tilde and here V tilde identically 0. Okay, so then when we push this distance is h, then this will be tau h of V tilde, and this is all this is tau h V tilde equal to 0. Okay, so this is what we have here. Okay, so now another corollary. Let V belong to H1 of Rn, then limit h tending to 0 norm tau hv minus v 1 Rn equal to 0. So proof, we know norm tau hv minus v mod 0p Rn anyway goes to 0 as h goes to 0. We have seen this long ago. Now d of tau h v by dxi is nothing but tau h dv by dxi, and therefore this implies that so now you have mod d by dxi of tau hv minus dv by dxi 0p Rn also goes to 0. So this is in fact true for all p. I have just stated it for p equals 2, and therefore this result is immediate. Okay, so now we have all that we need to do this. So theorem. Let n be greater or equal to 2, then kernel of gamma naught equals h10 of Rn plus. So proof. So we need to show, only kernel of gamma naught is contained in h10 of Rn plus, because other inequality, other inclusion is already done. Okay, so So let V belong to kernel Gamma. So then V tilde extension by 0 belongs to H1 of Rn, as we have already seen. So now let us go back to our friend. So zeta in D of Rn, support of zeta contained in B02, zeta identically 1 on B01, 0 less than or equal to zeta less than or equal to 1, and zeta k of x equals zeta of x by k, and therefore zeta is identically 1 on B closure 0 with radius k. Okay, and zeta k is in D of Rn as well. Okay, so now we have seen this again many times. Zeta k of V tilde converges to V tilde in H1 of R. Then zeta k V tilde is in kernel of gamma naught, and zeta k has compact support, so vanishes outside the compact set, and also for xn less than 0, because V tilde itself vanishes for xn less than 0, so zeta k V tilde will also vanish this. So let eta be arbitrarily small. Okay, now choose k such that norm V tilde minus zeta k V tilde in 1 Rn is less than eta over 3. Okay. Choose H positive small enough such that if H tilde equals H times H of En, then norm tau H of zeta k V tilde minus zeta k V tilde 1 Rn is less than eta by 3. Again, this is possible because k is now fixed, and now we are going to simply applying this corollary here. Then tau H of zeta k V tilde has compact support, again vanishes outside a compact set, in Rn plus, and vanishes for all x in Rn plus such that xn is less than h. So let support of tau h zeta k V tilde, okay, let's not, I won't call it support because it's not a continuous function, outside a compact set k, let us take. Okay. Okay. Now if rho epsilon, if epsilon is small enough, support of rho epsilon star tau h zeta k V tilde is contained in the ball center origin radius epsilon plus k, and this is still contained in Rn plus, for epsilon greater than 0 sufficiently small. And this is sum of two compact sets, so this is compact, and therefore rho epsilon star tau h zeta k v tilde belongs to D of Rn plus, because it's C infinity function and its support is compact, and therefore this is in D of Rn plus. So now you take choose epsilon small enough so that above condition holds, and that is the support is in D of I is in Rn plus, and you have that norm of rho epsilon star tau h zeta k v tilde minus tau h zeta k v tilde in 1 Rn is less than eta by 3. Again you can do this because rho epsilon star h1 function goes to that function as epsilon goes to 0. So if you take, so then this implies phi eta equals rho epsilon star tau h zeta k v tilde belongs to D of Rn plus, and you have norm phi eta minus V in 1 Rn v tilde 1 Rn is less than eta, because by triangle inequality you have 3 times eta by 3, and this implies that norm phi eta minus V in 1 Rn plus is also less than eta, and this implies that V belongs to H10 of Rn plus, and that completes the proof. Okay, so this proves the trace completely. So remark, it can be proved similarly that if gamma equals gamma naught, gamma 1 up to gamma m minus 1, then kernel gamma is in fact Hm0 of Rn plus.